Welcome everyone, those of you just joining. So this is the ZK and restaking panel. On the panel we have Mike Silagadze, CEO and founder of ether.fi. We have Federico Carrone, aka Fede or Fede's intern, the founder of AltLayer. We got Ron Turetzky, who's the lead engineer at Opacity, and Ishaan, the protocol researcher from EigenLayer.
Hey guys, I don't know how we're going to follow up Ismail's and YQ's talks, but we have Mike from ether.fi, we have Fede from AltLayer, and we have Ron from Opacity. So I think we'll give it a good shot. But yeah, great to meet guys. Really excited to have this talk with you about the intersection of ZK-X restaking. Can you give a brief intro to yourselves and your project? Would love to learn more.
I guess I'll go ahead and start. So my name is Ron. I am at Opacity. Opacity is an EigenLayer AVS. What we do is ZK-TLS. If you've heard of this narrative, essentially we're able to prove private and public data by doing an MPC ZK session with a client. We do this through our distributed network powered by EigenLayer. And yeah, very excited to be here.
Love it.
I'm Fede. I'm from Lambda class, an engineering company on AltLayer, a verification network for CKPs. We believe that CKPs are going to eat the world they're going to be bigger than blockchains. So we create the verification layer for it.
Hi, everyone. My name is Mike. I'm founder and CEO of ether.fi. ether.fi's goal is to make DeFi accessible and easy for users. So we have three products: ether.fi Stake, ether.fi Liquid, and ether.fi Cash that help you save, invest, and spend your crypto in real life.
Awesome. So we have two ZK projects and an LRT that's allocating in ZK projects and doing some fun stuff with ZK rewards that we'll talk about later. But yeah, one thing I'm curious about is that every time I hear about zero knowledge, I hear it with respect to scalability. That, zero knowledge rollups are going to be the future and scale Ethereum. But it sounds like we're using ZK for more than just scalability. Can you tell me how does that relate? What types of use cases does ZK enable from first principles, and how does that relate with your project?
Yeah, sure. Another thing ZK is good for is obfuscation, right? In our use case, for example, one of our partners, Teleport. You are proving to Teleport that you received some ride offer at some price, and they're matching it. And that's great. But you might not want to expose to them even the exact price or your authentication details and so on. And adding a ZK part of our stack allows us to, for example, prove that we have calculated that your ride offer is lower than the average without ever having seen your ride offer, right? So it's not a scalability issue, but still helps us out.
Yeah, I believe it's not only impacting rollups, even the L1. Nowadays, Solana is using ZK for compression. On Ethereum is going to long-term. My bet is that it's going to use Structs. It's going to be used for the state transitions. So even the L1 long-term is going to be ZK plus staking. On the application side of things, you have obviously rollups that are just computation engines that increase the throughput of Ethereum or any blockchain. But you can also do, for example, bridges. We invented the line because we wanted to have safe bridging between L2s, and it was not possible with the current design of bridges. So what we did is like a simple verification layer that can verify the state of each rollup. On a user deposits some money in a contract, you prove it, and you can remove the money from the contract as a market maker once you send the money to their chain to the user. So you can do bridges, you can improve the L1, you can do L2s, and also you can do things like, for example, you want to incentivize market makers to keep their money in difficult times when there's some volatility, and you can pay people on proof that they didn't remove their liquidity on the L1 or L2 with ZK. So the short of it is, I believe that any type of computation will be proven. Right now, it's a little bit expensive and slow, but long term is going to be cheap, so everything will be proven.
So I'll give two examples. One, I'll just piggyback off of the example Ismail gave with Lagrange. ether.fi is going to be using Lagrange to offload some computation from our smart contracts to calculate cashback rewards for our ether.fi Cash product. So that when you buy a latte or whatever, your 3% cashback is automatically calculated and dropped right into your wallet. Honestly, the only alternative to that is us just doing it manually off-chain, which is possible, but not in the spirit of what we're trying to do with ether.fi. Another use case is, as was mentioned here, is transaction privacy. What we don't want is every time you go buy that latte, that's broadcast to the world. And so there's definitely an application in using ZK to be able to obfuscate that and make it hard to trace who's spending when.
That's really cool. It sounds like there's a few things we're mentioning. One is succinctness, which enables the scalability. Two is this notion of privacy, which is everything is public on the on-chain data, like the world computer that is Ethereum, and we're trying to not necessarily obfuscate it, but make it so that people can transact as they do normally without sharing with everyone. And then three is this idea of verifiable computation, which means we do some off-chain computation, which is too complex or too gas inefficient on-chain, and then bring it back on-chain. I want to bring this back to what the panel is called, right? ZKX restaking. Zero knowledge is typically thought of as this endgame, and restaking as this new paradigm that enables cheaper crypto economic security. And they're seen as going like one against the other. Is the future ZK or is the future crypto economic security? But I think there's this very cool intersection area, and you guys are all in this area. So I'd love to understand, what does that intersection look like from you? And maybe Fede, if you want to start.
Yeah, sure. So a few months ago, I had a debate about this on Twitter. I don't think the two things are contradictory. At the end, you need to verify the CKP that it's just mathematics somewhere. Right now, you're doing it on Ethereum has cryptoeconomic security. So I don't see how the hell the two things would be contradictory. Like, if you need to verify it somewhere, unless you do it on client side, if you want to have some source of truth that can say, yeah, this CKP is correct, there's always economic security behind everything. It's like that meme where you have the astronaut, I don't know if you know it, and there's another guy saying, yeah, the US always keep the economic security at the end. I believe that in our case, what we're providing to developers is the ability, the first product that we're doing, the verification layer, is that you can do it in a faster and cheaper way than Ethereum, obviously with less security. So it's just an option on depending on what you're doing, it makes sense to do it or not. For a rollup with billions of dollars, probably doesn't make sense. But if you're doing a bridge that needs to transfer $10 and you want to do it super cheap and super fast, you're going to verify it in the line. So I think it's just a question of options for developers. Like, I can accept a lower level of security for the verification using less cryptoeconomic security. But with that, again, different options on the things I can do thanks to EigenLayer.
Yeah, I think what we're seeing now is, and I think we're going to go more and more in the direction of this, but what we're seeing with companies like Authentic or Layer is this idea of composability, right, in shared security. So this idea that, and for example, in our protocol, ZK is one part of a larger sort of scheme, right? And so I think that if you go at it from, okay, the ZK proving part is part of the protocol, it might not necessarily be the scaling part. It just might be part of the consensus part. Then there really is no contradiction. The technology is so flexible, it can be used for anything. And if we're looking at this composability narrative, I really think that it makes sense to put ZK provers through shared security services as a composable module that you can add to your protocol. And then you can choose the level and the application of the ZK proving. Yeah.
I think that was great. I don't know that I have anything to add.
Can I add another example? Yeah. We're doing a small rollup called Rogue on, you get a proof of the execution at the end, but that takes time. Obviously, there's some latency on the proving. What you want to do is you can add capital that can be slashed or even with pre-confs to get a sense of what's going to be the result when you get the ZKP. It's a way of saying to the world, I'm committing some money or I'm paying somebody to be slashable in case they lie, that this is going to be the result of my execution. So again, I think it's just options on your changing capital for mathematics depending on what you're doing.
This is a perfect example of composability, right? Where you're leveraging both of them to give a better result.
Yeah, I fully agree.
I love that. It sounds like there's the crypto economic security may be cheaper at some levels of TVL and volume. And then after a certain level, ZK proofs have more fixed costs. That's my understanding of what you guys are saying. Do you want?
Can you repeat that? So you're saying that up to a point it's cheaper to do economic security, and then with ZKPs it becomes linear. I got it right?
Yeah, so my understanding is, let's say we're doing a settlement transaction from a ZK rollup back onto mainnet. Or let's just say any rollup onto mainnet, and we want to do a fast withdrawal. And then the cost of the crypto of the crypto economic security method will scale linearly with the amount of volume or that we're trying to bridge back down to mainnet. And the cost of the zero knowledge proof is going to be more stable regardless of the volume. It'll be more with respect to number of transactions, maybe. So you could say
When you say volume, you mean like blob data, right? Like
Yeah. Exactly. So almost think of it like if this cost of the crypto economic security was scaled linearly, then at a certain point, the zero cost of the ZK proof is relatively stable. And then once the zero knowledge proof is cheaper, then you just use that.
for this use case. Yeah.
In my case, I think I agree, but I don't fully. So, yeah, I agree, but I think that the thing is that at the end, CKPs are gonna be cheaper always, long term. From my point of view, at least, long term for most things, they're gonna be cheaper. The problem is that they're too slow yet. For example, the other day I tweeted that you can prove about 200 million gas. That's something like 10,000 transactions of Ethereum with $1. That's so cheap that doesn't that's gonna make with Circle Starks and hardware proving with Fabric and other things.
Specialized hardware, etc.
Yeah, it's gonna become like that. This is the most costly moment in life that ZKPs are, because it's gonna go down. So I think that at least for now, for me, the reason why cryptoeconomic security makes sense is that the issue is that for some computations, it's not for AI, for example, you cannot do a ZKP. You can for a few things, you can, but not for huge things.
Yes. Sorry, I was just going to riff on that. This is the specific use case that you brought up, I agree with, right? But I think that, and this is what I was hitting on earlier, is that there's no one correct way to use ZK proofs, right? And in our protocol, ZK proofs can be the method in which all of the nodes convince the other nodes that some attestation, you can calculate the data in it and produce some sort of condition. But this is not even going on chain. This is just part of the consensus mechanism, right? And in this design, it's really hard for me to make, this is as in general, it's hard to make a definitive statement of like, oh, okay, ZK is always going to be like the scalable solution for every use case or so on. And also there are use cases that you can't really use zero knowledge proof for. For example, I can have the best zero knowledge proof machine in the world with the best software and run a program, and then I can spoof the internet ports to have random data that I choose. There's different sort of things that ZK really excels at. And then there's things that is not its problem space. Yeah. You want to respond to that maybe? Or?
No, I fully agree. I'm sometimes feel a little bit lonely in Ethereum because I'm like an engineer with 20 years of experience building things. I love ZKPs. I love mathematics, but even proof of work for me makes sense for some use case. So proof of work that's working capital, TEs that is hardware on ZKPs, the four things are useful depending on the context. So I'm not the maximalist of any of those. I love ZKPs. I'm just like, sometimes I think it's, as you're saying, it's a question of like where you use it for what.
I love that. Like, choose the right solution for whatever the situation is. Let's shift towards applications. I want to know how you use zero knowledge proofs in your application. Fede, I'll start with yours because we'll shift from more infra to more app-based. And you have this decentralized network of zero knowledge proof verifiers. And my understanding, correct me if I'm wrong, is that the thesis is that Ethereum is not optimized for verifying ZK proofs. So if we have this layer, I don't want to call it a layer 2 because it doesn't have these blocks necessarily, but if we have this layer that is really good at verifying ZK proofs and then pushes it back to Ethereum in a format that Ethereum is best suited to understand, that's beneficial. What are some use cases where people would push ZK proofs to you? For example, would ZK rollups do that? Would Opacity do that? Say more.
Yeah, sure. So in our case, we have two modes. One that is like the fast mode, that is it's a group of 100 nodes, or probably more in the future, that they re-execute on they sign, saying with BLS, with the signature, they saying, yeah, I approve that this is correct. they attest it, and then they send it to somebody that checked that's correct, an aggregator, and then the aggregation of the signature is sent.
You
to
just send them any arbitrary data for ZK proof. Like
Yeah,
they're agnostic. Yeah.
we don't even touch data. We just get the proof. You can post the data in a DA layer, in S3, wherever you want. It's just, we have this data, we have this proof, we want you to verify the proof. And then we post the Merkle root to Ethereum saying, this is correct, this is a full batch of things. That's the fast mode. Then you have the slow mode that is more like a normal aggregation technique that is slower and more expensive than the one I just said, but it's more secure. Like the second one is more like an L2. And the first one is more like an L1 in some way that posted something to Ethereum. So what type of things you can do? First of all, it's going to be so stupidly cheap because you can send like more or less 10,000 transactions, 10,000 proofs per second. So the bandwidth becomes the problem, not the verification.
And the BLS signature is way lower gas than any ZK proof.
Yeah, exactly. And actually, we're trying to get EigenLayer to approve one PR that we did with Lambda that lowers the BLS signature a lot.
Oh, I worked on that as well.
Cool. We are having some issues with that. It was like 600K gas for some reason, and we can lower it to 250 something. It's not only the BLS signature, it's the full contract on how they verify it.
APK caching? Is that what you guys are doing?
No, it was just like very simple. We changed, we can talk about that later, but it's so cheap that any type of thing that you do, you have a program in Rust and you want to prove it, you're a developer, and it will be less than 1 cent to send it to the layer. The core idea or the core thesis is like anybody being able to write Rust and using any type of CKVM like SP1, Jolt, RIC0, etc., will prove it and send it. Concrete examples, like we have more than 30 teams that are going to use EigenLayer that is going to mainnet in a few weeks. We have from CKML to bridges to people doing rewards, like the one you said, Brevis with Uniswap, on too many things. So from my point of view, it's the other way around. I don't know what cannot be proven. So anything that the blockchain does will be proven and verified in us.
Makes sense. I know we're running low on time, so I'll move on. Mike, I know you're talking about this points meta that everyone hates. And yeah, sorry, I'm done with points at this point. Pun not intended. But you guys want to use ZK proofs instead. Say more about how say more about this new paradigm.
First of all, points are great. Come on, who doesn't love points? Points are here to stay. I'll just say that, whether you love them or hate them. Yeah, so I gave 2 examples of how we're using ZK proofs in our protocol. I think the more general observation is pretty much any DeFi protocol that you look at has secretly in the back or it's somewhere in the basement, a whole bunch of centralized components that they don't talk about that are running on some sketchy Python script on somebody's machine. More or less, pretty much any protocol has some elements of this. We have lots of these things. For example, the way that we do rebasing, pretty much any liquid staking project has to figure out, let's say once a day, how much ETH do we have in the system? And then you have to rebase and recalculate the value of your tokens as part of that. And in all cases, there's varying degrees of centralization that are involved in that, where if that centralized system breaks, basically the liquid staking thing just stops working. So in our case, same as Lido, we've got our node operators that are running this Python script, hopefully not just in their basement. So they're running this script, calculating it. They'll do a little consensus thing. All right, great. Every once a day, the rebase is computed. That's another really great application where it would be nice to make it a more decentralized process with some sort of proving mechanism to actually be able to, in a reliable way, ensure that the rebasing is happening correctly every day.
That's super cool. Last question, because we're low on time and everyone is hyped about the crypto's airtag moment. Tell us about how you guys, or an application built using zkTLS.
Sure. So the first app that I talked about, Teleport, you prove to them that a different competitor offered you a rideshare at some price, they'll match it. Boom. You have sovereignty of your data, you get rewarded for it. Another app we have is Daisy, where people on social media who are promoting some product or so on can prove that they have actually gotten a certain amount of view count on some video and get rewarded for it. Again, sovereignty of the data means it's a better situation for you. The third use case is EarnOS, which is very interesting, where essentially like instead of some company going to some advertiser spending some money to get you, You just go directly to the company, you get rewarded for it, and you can cash out the reward directly to a card that's in the app and spend it instantly. So these are some use cases, but in general, I think the direction is your data should be your own, and where it can profit you, you should be able to profit.
I think, first off, let's give it a hand for these panelists, because I think they really just showed that the future of ZK and restaking is not just scalability, but it's all of these so many interesting use cases about verifiable computation, bringing data, like private data over and securely, and being able to verify proofs much more efficiently. Thank you guys.